Okay, good evening, students. So today we will formally introduce the terminologies associated with probability. Hope you hear me, right? Someone respond, please. Do you hear me?
Yes, ma'am.
Fine. Okay. So when we say an experiment, okay, it is a repeatable procedure, okay, with well-defined outputs, okay, or possible outcomes. Okay, so two things are important. One is that I should be able to repeat that experiment. Okay, that means that the procedure of the experiment itself is well defined. The other one is we have well defined possible outcomes. That is, we know the set from which the outcome can appear. Okay, both are known. Okay, so that is an experiment. And sample space we denote it either with S or omega. Okay, this is capital omega. This is the notation that we use, and that represents the set of all possible outcomes, okay, of the experiment. So that is the sample space, and an event is a subset of the sample space. Any subset will serve as a event. Okay, but mostly in practice, okay, an event will have some characteristics which will distinguish a subset of the outcomes from the other. Okay, say for example, if we say if we take the set of days, okay, we days as sample space, like say Monday, Tuesday, Wednesday up to Sunday. Okay, so I can distinguish or take one subset of this set, say Saturday and Sunday, and this event is nothing but weekend. Okay, or we can say weekend holidays. So this subset is clearly having a property that it is although it is the days of the week, okay, we can means we just mean the Saturday and Sunday, which are holidays, right? Weekend holidays. So we associate some characteristics with the event. Okay, and probability function is a function, okay, that is going to assign probability value for each of the outcome. Okay, so that is a probability function. Okay, so with this definition, let's see an example. Okay, suppose if I toss a fair coin, okay, what is the experiment according to this definition? It is nothing but tossing a fair coin, and I should report if it lands in heads or tails. Okay, so this will be the experiment. So what will be the sample space? All possible outcomes of the experiment, right? So what will be the sample space?
Head and tail, ma'am.
Good, great, okay. Is it Sedaram?
Yes, ma'am.
Yeah, great Sedaram. Okay, so head and tail will be the sample space. And what about the probability function? Suppose if we consider, okay, so it is not considered. We have already stated that the coin that we are tossing is fair. Okay, that means that all the outcomes get equal probabilities, and only there are two probabilities. So I'll say head is 0.5 and tail is probability of tail is 0.5. Okay, so you can try this yourself. Tossing a fair coin 3 times. Maybe one of you can quickly say what is the experiment. And what is the sample space, and what is the probability function? Padmini, Padmini? Yeah. Can you just say what is this? Okay, nobody wanted to try. Okay, so it's okay. Okay, so experiment tossing a fair coin 3 times and list the results. Okay, results are nothing but the observations that we see on. I mean, what is the face of the coin that we see on each toss? Okay, and what will be the sample space? All the 8 possible outcomes. Okay, which we have already seen. Okay, and since again it is a fair coin, so all the outcomes will get equal probabilities. Okay, so each one of the outcome is going to get 1 by 8, okay, as the probability. Now what about this one? We want to measure the mass of a proton. Okay, so this is a scientific process, right? So the experiment is we have to follow some well defined procedure, okay, to measure the mass of the proton and report the result. Okay, what about the sample space? It is slightly different from whatever we have seen so far, right? So the mass of a proton, okay, I mean before that, okay, what is this? Is it a typo? The square bracket and open bracket? What is the meaning of the square bracket and open bracket? Should I have a open bracket here as well or a close, I mean the square bracket here? I think some easy students should be able to answer, okay? You read lot about this proton and neutron, right? Electron basically.
Square bracket means included zero, ma'am.
Okay.
And the curly bracket means excluding the infinite value, ma'am. Until from zero,
Okay, thank you. Yeah,
something value
thank
before infinite.
you. Yeah, thank you so much. Who is this?
Say the Ram again, ma'am.
Sedaram. Okay, thank you, Sedaram. Okay, so this is not a typo. Okay, we call this as a close bracket. Okay, and this is a open bracket. Okay, so as Sedaram rightly said, when you have a closed bracket, okay, that means that in this interval between 0 and infinity, okay, the 0 is included. Okay, that means that the mass of a proton can be 0. Okay, but we will not include this infinity as a value. Okay, it is just before the infinity. Okay, so that's what the open parenthesis mean. Okay, but this is a range. Okay, unlike the other sample spaces, okay, where we are able to list out the samples, right, or we are able to list out or enumerate each of the possible outcome. Okay, so that is discrete. Why discrete? Because I'm able to independently enumerate it. Okay, so that is a discrete sample space. Okay, and if you consider the previous example, okay, here the sample space is discrete because I am listing it out, and it is finite. Okay, means that I'm able to list out all possible outcomes. Okay, so this sample space is discrete and finite. Okay, but here, okay, it is clearly you can see that this is not a discrete sample space because mass can take any floating point value. I can say 0.25, okay, that is also a value. 0.225, that is also a value. Okay, so here the sample space is continuous, okay, and infinite. Okay, continuous and infinite. Okay, and okay, probability function. Okay, since the outcome lies in the continuous range, okay, there is no probability function as such what we have listed before, but we have probability density function. Okay, we'll see what is probability density function when we see the distributions. Okay, and remember that. Okay, so probability density function is also a probability function, but it is not like what we have uh, discussed with discrete random spaces. Okay, so this probability density function is also giving the probability values, but if you take the probability of a particular sample, okay, it will be zero. We always integrate between some range. Okay, so that's how this probability density function differ from the simple probability function. Okay, I hope you understand. Okay, so here I can ask what is the probability of observing three heads. Okay, so I have a probability associated with it, which is 1 by 8. Okay, with a discrete sample space. Okay, but here when the sample space is continuous, if I ask what is the probability that a proton gets the mass to be 0.25, it will be 0. Okay, I cannot find out the probability of a individual sample. Okay, we always take a range. Okay, what is the probability that the mass of a proton is between say 0.25 and zero point 0.5? Okay, so this we can compute. Not every individual will get only 0. Okay, and infinite discrete sample space. Okay, example for an infinite discrete sample space. Okay, so we are going to count the number of taxis or cars, okay, that pass GC Salem during this AA and ML class. Okay, so here there could be zero number of cars that have passed. Okay, or it could be just one car that was passing by GC Salem when we are doing this AI and ML class, or two, or it can, there can be many cars. Okay, so it is an infinite set, but the samples or the outcomes are discrete. Okay, so it is infinite discrete sample space. Okay, and for such things we have probability mass function. Okay, which we will deal, but usually the problem of the sort, okay, one probability mass function, okay, is Poisson distribution. Okay, we'll see in detail what all these things when we deal with probability distributions. Okay, now the choice of sample space. Okay, how we can decide what should be the outcome of the experiment. Okay, or how the outcome of the experiment should be noted. Okay, so it is a two die case. Okay, suppose you have a single die. Okay, one die and you are rolling it. Okay, the sample space and the probability function is like this. Okay, the sample space will include 1 2 3 4 5 and 6. Okay, and we assume that the die is a fair die. Okay, and each of the outcome will get 1 by 6. Suppose if I have two dice. Okay, what could be the sample space? Any guess?
36 sample spaces, ma'am.
How?
Ma'am, 1 comma 6, 2 comma 6, likewise, sample space may increase up to 6 comma 6.
Okay, okay. So this is say that you are right. Okay, so one choice would be I will note down. See, what is the experiment here? I toss or I roll two dice, right? So I can note. So assume that the two dice are in two different colors, and you say red and blue, and you say that red is one and blue is two. Okay, that is red is die one and blue is die 2. Okay, and you note down what face is on the top of the die in the first die, which is the red one, and what is the face on the blue die. Okay, and this will give you a pair. Okay, and how many such pairs are possible? As Sevaram rightly said, okay, you will have 36 different pairs, right? It is a Cartesian product of the set 1 to 6 and 1 to 6 again, right? I can get 1 for the first die and 1 for the second die, 1 for the first die and 2 for the second die, and so on. Okay, so we will have 36 such outcomes. Okay, so this is one possible outcome that we can note down. Is there any other way that I can do? Because we are talking about the choice of sample space, right? So this is one choice. Is there any other way I can note down these results? See, I hope the experiment is clear. We are just hold on, okay? Just 2 minutes, okay? So what is the other? What would be the other choice? Any guess? Okay, so this is the first choice. Okay, we just note down the output or the outcome of the first day, and this is the outcome of the second day. Okay, so you have six choices here, and we assume that the dies are fair, and we will get equal probabilities across all possible outcomes. Okay, the second choice of outcome could be, I instead of noting down this pair, okay, we could say I will just note down the sum of the two faces on the first day and the second day. Okay, we can simply say, instead of noting down like 1 comma 1, I'll simply note down this as 2. Okay, and I'll simply note down this as 3. Okay, this is 36, 12. Okay, and so on, right? Okay, so this is one another way of representing the probabilities. Okay, in this case, see the probability function. I hope everybody is hearing me, right? Are you with me? Yeah. So note down the probability function here. Okay. See, unlike the other probabilities function that we have seen so far, okay, here the probability function is not distributed uniformly. Do you see that? 2 is getting 1 by 36, 3 is getting 2 by 36, okay, 4 is getting 3 by 36. How do we compute this one? How did I assign values to this? Just randomly some values? Or do I have any systematic way of doing it? How about this one? How many of you understand this one? Is there any doubt on the sample space?
No, ma'am.
Okay, so if there is no doubt on this, probably you should be able to get this, Sedana.
Yes, ma'am.
How?
Ma'am, for outcome of 2, the value may be 1 comma 1 itself, ma'am. For outcome of 3, there are two possible
Okay.
variants, 1 comma 2 2 and 2 comma 1. These two may
Okay,
get
great.
value
Okay,
of
so yeah, okay. So we can actually derive this table from the previous one. Okay, so we have the sum, right? 1 plus 1 will give you 2. Okay, and there is only one possibility by which you can get this 2. Okay, so the probability of getting the sum to be 2 will be 1 by 36. Okay, and when you have the sum to be 3, the first dice can be 1, the second die can be 2. So this is one entry. The other entry is first die is 2, the second die is 1. Okay, so this is another entry. So you have two, outcomes that corresponds to the sum of two dice to be 3. Okay, so you will add this probability with this one. So 1 by 36 plus 1 by 36, and thereby you get 2 by 36. Is it okay? Okay, so you can list out all these, how many combinations you have to get all these things. Among the two choices of probability functions, which do you find as, will be better representation? Or choosing the sample space, okay, rather than saying the probability function which depends on the sample space, which choice of sample space will be better, representing it this way or the other way? Because both in both the cases we are doing the same experiment. Okay, we just roll two dice. Okay, and we are just representing the sample space in two different ways. Which choice will be better?
the second one,
Is
ma'am.
there any hard and fast rule? Second one, why?
The sample space is little bit compared to the first choice, ma'am.
Okay, sample space is small, so the inferences can be
Easily, ma'am.
faster. So that's your claim. Okay, okay. So that's also a point. Yes, the computations will be simpler. Because some computations are already done here, right? So that is one point. Any other point in favor of the other one? Other representation? Okay, so I'll post a series of question and you are going to answer. Okay, find the probability of observing same face on both the dice. So you have both the tables with you now, right?
It is
If you
6 by
have, if you
36.
do not have a copy of this one, just take a copy of this one. Okay, you can just click on the, I mean, just take a photo of that snapshot. Okay, so now you have both. Here everything is 1 by 6. Sorry, 1 by 36. Okay, so now tell me, find the probability of observing same face on both dice.
6 by 36, ma'am.
6 by 36. Okay, so that's the right answer. Of course, Sedaram. We'll come to that. Okay, find the probability of observing a value on the first die, one less than the second die.
5 by 36, ma'am.
5 by 36. Who is this?
Hari Prasad, ma'am.
Hari Prasad. Great. What about the last one? The probability of observing the sum of two dice is 7.
1 by 2 by 36 or 1 by 4 by 36, ma'am.
4 by 36?
I think 2 by 36 is right,
No.
ma'am.
2 by 36? Uh-huh. 6 by 36. Who is this? Padmini. Great, Padmini. Okay, so how did you find this, Padmini? Hmm. Great. Okay. So I think none of you had used these tables, I guess, right? In all the cases, I think you have listed out. See, what is the use of these probability functions? Okay, these probability functions are the ones supposed to give us these values. Okay, so with the first question, okay, the probability of observing the same face on both the dice. Okay, can I get that value from this one, this table? Probably. Okay, what should I do? I should add 1 plus 1 is 2, 2 plus 2 is 4. But this 4 I will not get just by 2 plus 2. Okay, there are other choices which will also give the sum as 4, right? I have 1 comma 3 and 3 comma 1 and 2 comma 2. All these three things will give 4 as the sum. Okay, so I cannot directly take these things and sum those things and get the answer. Okay, rather if I use this table, I know that I have to add this diagonal one, right? 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6, right? So this is, so I have 6 pairs which will give me this one. So 6 into 1 by 36, or you can say 1 by 36 plus 1 by 36 plus 1 by 36, 6 times. Okay, so which is basically 6 into 1 by 36. Is that fine? I need not list out that one. You can infer these things. Okay, you can infer the probability values from this table itself. Do you follow that? Yes or no? Anyone? Yes or no? Am I with you?
Yes, ma'am.
Okay, fine. What about the second one? We have the probability of observing a value on the first die, one less than the second die. Okay, again, this table is a problem for me. I am unable to compute it. Right or not? I do not
Yes.
know which die was giving me this one. Okay, like this one. Okay, one die is less than the other, but only one choice will satisfy our condition. The value on the first die is one less than the second die, right? When you get 3, so it is 1 plus 2. Hold on. Class எடுத்துட்டு இருக்கேன், போங்க. So you have only one, the 1 comma 2 will be the entry in this one, okay, corresponding to the sum 3. Okay, the other will not get satisfied. Okay, again, if you see this table, okay, we are little bit clear. Okay, 1 less than 2, and you have one less than, I mean, which is just one value should be more, right? So you have the pair 1 less than 2, 2 less than 3, 3 less than 4, and so on, right? So from this table I can compute that probability little easier compared to this one, right or not? What about the last question? Find the probability of observing the sum of two dice is 7. if you take this one, I need not even compute. I can directly go and fetch this value and say it is 6 by 36. I need not even list out because that is what we have noted down. Okay. What about this one? Here we have to find out which pair will sum to 7. Okay, I have to say 5 plus 2, then 4 plus 3, okay, and 6 plus 1. All those combinations I have to list, I have to find out and take the sum of those entries. Okay, so if you see the number of queries that comes to this problem, okay, the favor is on this type of sample space. Okay, but we cannot have a hard and fast rule to decide on this. Okay, it depends on the context in which we are working. Okay, if the query is going to be the sum based on the sum, okay, then this choice would be better. Is that clear? Yes or no?
Yes, ma'am.
Okay, so what we learn from this is that given an experiment, we have more than one choice by which we can represent the sample space. Okay, that purely depends on the context in which we do the experiment. Okay. Okay, so next is the events. Okay, I think this is the last topic. An event is a collection of outcomes. Okay, that is, it is the subset of the sample space. Okay, so sample space will have the entire possible outcomes. Here we just have a collection of a subset. Okay, an example, you flip a fair coin 3 times. An event E in the setup could be you get exactly 2 heads. Okay, so the event here is exactly 2 heads. Okay, so what will be the event E? You have the sample space for flipping fair coin 3 times, right? So what will be the event E? See, it is a set again, okay? It is a subset, okay? So it's a set. So what are the entries in E? Out of 3 flips, you have exactly two heads. So what is the output? Or what is E? Come on.
Set of three values, ma'am. HHT, THT, sorry, THH or HTH.
Thank you, Sedaram. Okay, so this is the event that we are trying to, enumerate. Okay, and what is the probability? It's going to be 3 by 8. Okay, 1 by 8. So the total number of outcomes, since this is fair, we have total number of outcomes to be 8. Okay, and this is a fair coin. That means that every outcome is equally likely. So we have 3 events. We have 3 outcomes in this event. Okay, so the probability of this event will be 3 by 8. Okay, and these are some probability rules, okay, which we have already learned in our school. Okay, we have the sample space S with n outcomes, omega 1, omega 2, etc. up to omega n. Okay, and each omega is a member of S. Okay, and the probability should be probability of any omega. Okay, any outcome should be between 0 and 1. Okay, both inclusive. Okay, and if you take the total probability of the event, it should be or total probability of the outcomes, not event. Okay, total probability of the events, it should sum to 1. Okay, so you have the summation from 1 to n. I sum the probability of all possible outcomes here. Okay, and that should be at most 1. Okay, or we can represent this as I mean, for every member that belongs to S, I compute the probability of that and make a sum that should sum to 1. Okay, and the probability of the event A is P of A is equal to sum of all the entries in A. Okay, and sum of all the probabilities of the outcomes of A, we will sum it and get the probability of the whole event A. Okay. Now, how this probability is associated with set operations on events. Okay. Suppose you have a sample space omega. Okay, consider a sample space omega, and you have three events A, L, and R. Okay. Now, the complement rule says if you have an event A, the probability of A complement, okay, will be 1 minus P of A, okay, which is this figure, okay. You have an event A and A complement will be anything other than A, okay. So that will be this blue region, okay. And you know that the probability of the entire sample space, that is this rectangle, to be 1, right? So if you have some, this A, event A may have some probability P of A. We are not bothered about what value it is. We want the value of this probability of A complement. Okay, so that will be simply 1 minus this value P of A, which should give you the probability of A complement. And when you have disjoint sets, okay, if L and R are two disjoint events, okay, which has no overlap, then the probability of L union R, okay, is probability of L plus probability of R. Okay, I'll consider this and or this one. Okay, so it is, since it is union, it's going to be either this or this one. Okay, so you have addition. Okay, and if you have the overlapping sets, if L and R are overlapping, okay, we didn't say that they are disjoint. Okay, so that means that it could have overlap. Then using inclusion exclusion principle, you can compute this probability of L union R as probability of L plus probability of R minus probability of L intersection R. Okay, so which is given in this figure. Okay, so example. Okay, if the probability of even number is 0.6, what is the probability of odd numbers? Okay, take some sample space, okay, which is biased towards even numbers. Okay, so it is 0.6, even number is 0.6. What is the probability of observing odd number? Or in general, I'll say probability of odd numbers.
0.4.
Point 4.
0.4. Yes, good, great. Okay, because we know that even numbers and odd numbers are, complement to each other, right? So we can say it is 0.4. Now consider two events. Okay, one is A, which represents X is a multiple of 2. Okay, and B is another event which says X is odd and less than 10. Okay, suppose if P of A is 0.6 and P of B is 0.25, what is the probability of A intersection B? What is A? A is, yes,
0.
somebody,
0.
Zero,
yes,
ma'am.
0, exactly. Okay, it is 0 because A intersection B is null, right? Because X is multiple of 2. That means that it's going to be a even number. And B says X is odd. That means that A and B are complement to each other, right? So we will say that A intersection B is null. Okay, and therefore I don't have any elements in the A intersection B set. Therefore, the probability of A intersection B is 0. What about the probability of A union B?
0.85.
0.85. Okay, you have to simply add 0.6 and 0.25. Okay, since they are distant. See, when we say they are complement to each other, they are disjoint as well, right? So I can use the disjoint rule and say probability of A union B is probability of A plus probability of B. Okay, great. What about this one? Let A, B, and C are three events. Okay, the first event A represents X as a multiple of 2, B is X is a multiple of 3, and C is X is a multiple of 6. Okay, and we have probability of A is 0.6, probability of B is 0.3, and probability of C is 0.2. What is the probability of A or B? First, let's resolve this one. Okay, what is A or B? What is the event A or B?
A intersection B.
Intersection, it is R, right? A union, yes, yes. A union B. See, it is, see, either the outcome can come from A or the outcome can come from B. So it is a bigger set, right? I have A, either it can come from this or it can come from this, okay? It's a bigger thing. It includes both, okay? Even if it is disjoint, I don't mind. If it is A and this is B, doesn't matter. Either it can come from this or from this one. It is the union of, it is R, okay? Either this or this one, okay? So it is union. It is R means union, okay? And means it is intersection. It should happen here and here, okay? So that will represent the intersection, okay? So here R means we represent the union operation. Okay, now tell me, what is the probability of A union B?
0.7.
0.7. Yes, say
0.7.
the normal guess, right? Yes, yes, it's the right answer, okay? How but why? How and why? Is it Seduram? Who said 0.7? 0.7 is the right answer. I'll agree with you.
It
But
is Hari
how
Prasad,
and
ma'am.
why?
Hari Prasad, ma'am.
Hari Prasad. Hari Prasad. Hari, great.
Event of C is
Um,
nothing but A intersection B, ma'am.
event of
C
C is
A intersection B. If it is divisible by 6, but then it is divisible by both 2 and 3.
yeah, that's the point. Okay, so event C is actually, it is X is a multiple of 6. Okay, if it is a multiple of 6, then I mean 2 and 3 are factors of 6, right? Yes or no? So it is kind of intersection of both A and B. A intersection B is actually even 6. Okay, so we will use this inclusion exclusion principle, and we say probability of A union B is probability of A plus probability of B minus probability of C, and thus we get 0.7. Okay, great, Hari. Okay, so with this we'll end today's session. Um, Tomorrow I'm not handling any class. Okay, we'll take off. From Monday, I'll discuss the topics on conditional probability, and then we will go to the distribution and put a end to probability there. Okay. Thank you all for joining this holiday weekend evening. Thank you. Any doubt? If you don't have any doubt, we'll close.
Ma'am,
Yes.
ma'am, second example on less than one சொன்னீங்க இல்லைங்க ma'am.
எதுமா?
A die with the less than one அப்படின்னு சொல்லி செகண்ட் எக்ஸாம்பிள். இது இல்லைங்க மேம் முன்னாடி.
ஆ ஆ
அது கொஞ்சம் இன்னொரு டைம் சொல்லுங்க மேம்.
ஆ ஆ. இதுல என்ன பாக்குறோம்னாமா, இப்ப இதுல வந்து ப்ராபபிலிட்டி வந்து இப்ப சாம்பிள்ஸ் இப்ப இந்த எக்ஸ்பெரிமெண்ட்ல ரெண்டுலயுமே நம்ம என்ன பண்றோம், ஒரு 2 டைய ரோல் பண்றோம். ரோல் பண்றப்ப அதுல என்ன ஃபேஸ் நமக்கு வருதோ அதை நம்ம நோட் பண்ணணும். இப்ப இந்த நோட் பண்ற மெத்தட நம்ம எதை சூஸ் பண்ணணும் அப்படிங்கறது வந்து நம்மளோட ப்ராப்ளமோட பேஸ் பண்ணி தான் இருக்கும். ஒரே எக்ஸ்பெரிமெண்ட்டுக்கு எனக்கு செவரல் வேஸ்ல எனக்கு அந்த அவுட்புட்டை ரெக்கார்ட் பண்ண முடியும். ஓகேவா? அதை இல்லஸ்ட்ரேட் பண்றதுக்கு தான் இந்த எக்ஸாம்பிள் போட்டிருக்கேன். இப்ப 2 டைய ரோல் பண்றப்ப எய்தர் நான் வந்து ஃபர்ஸ்ட் டைல என்ன விழுந்துச்சு அந்த ஃபேஸை நோட் பண்ணுவேன். அப்புறம் செகண்ட் டைல என்ன ஃபேஸ் வந்தது, அது என்ன வேல்யூ, அதையும் நான் நோட் பண்றேன்னு வச்சுக்கோங்களேன். இது ஒரு சாய்ஸ் ஆஃப் ரெப்ரசன்டேஷன். இன்னொரு சாய்ஸ்ல நான் என்ன பண்றேன், அந்த 2 இண்டிவிஜுவல் வேல்யூவையும் தனித்தனியா நோட் பண்ணாம, இப்ப ஃபர்ஸ்ட் டைல 1 விழுந்திருக்குது, செகண்ட் டைல வந்து 3 விழுந்திருக்குது அப்படின்னா 1 + 3 4ன்னு மட்டும் நோட் பண்ணுவேன். சம் ஆஃப் 2 டைஸ் அந்த ஃபேஸ்ல உள்ள டாப்ல வேல்யூஸை மட்டும் ஆட் பண்ணி நோட் பண்றேன்னு வச்சுக்கோங்க. இப்ப இதுல நமக்கு இதுவும் ஒரு வேலிடான சாம்பிள் ஸ்பேஸ் தான், இதுவும் வேலிடான சாம்பிள் ஸ்பேஸ் தான். ரெண்டுமே சேம் எக்ஸ்பெரிமெண்ட்ல இருந்து டிரைவ் பண்ண அவுட்புட்ஸ் தான். சரியா? அப்படி இருக்கிறப்ப நம்ம என்ன கேக்குறோம் அப்படின்னா, எந்த சாய்ஸ் நமக்கு பெட்டரா இருக்கும். இதுக்கு வந்து ஒரு சிங்கிள் ரைட் ஆன்சர் நமக்கு கிடையாது. இந்த கொஸ்டினுக்கு வந்து விச் இஸ் பெட்டர் அப்படின்னு சொன்னா எனக்கு அதுதான் பெட்டர் இதுதான் பெட்டர் அப்படின்னு சொல்றதுக்கு எனக்கு டைரக்ட் ஆன்சர் கிடையாது. ஏன் அப்படின்னு கேட்டீங்க அப்படின்னா, அது நம்மளோட ப்ராப்ளம பேஸ் பண்ணி இருக்குது. இப்ப எனக்கு வந்து என்ன வேல்யூ வந்ததுங்கிறதுக்கு எனக்கு எந்த பாதரேஷனும் இல்லை அப்படின்னா, நான் வந்து இந்த சம் ஆஃப் 2 காம்பனன்ட்ஸ்ல தான் ஒர்க் பண்ண போறேன் அப்படின்னா ஐ எம் ஓகே வித் திஸ் சாம்பிள் ஸ்பேஸ். சரியா? பட் மோஸ்ட்லி எனக்கு கொஸ்டின் இப்படிதான் வருதுன்னு வச்சுக்கோங்களேன். இப்ப எனக்கு 2 டைஸை வச்சு பாக்குறப்ப இந்த பர்டிகுலர் எக்ஸாம்பிளுக்கு பாத்தீங்கன்னா இந்த ஃபர்ஸ்ட் சாம்பிள் ஸ்பேஸ் தான் நமக்கு வந்து ஈஸியரா இருக்கும். ஏன் அப்படின்னு கேட்டீங்கன்னா, குவரிஸ் எல்லாமே வந்து பாத்தீங்கன்னா சம்ம வச்சு நமக்கு என்ன கேட்க முடியும், சம் லெஸ் தேன் ஆர் ஈக்குவல் டு 3, கிரேட்டர் தேன் ஆர் ஈக்குவல் டு 5, இத மாதிரி கொஸ்டின்ஸ் இல்லைன்னா சம் ஆஃப் தம் ஈக்குவல் டு 7, இந்த மாதிரி கொஸ்டின்ஸ் தான். இதுல சம்ம ரிலேட் பண்ணி கேக்குற மாதிரி குவரிஸ் தான் நிறைய இருக்கும்னா ஐ வில் கோ வித் திஸ் ஒன். இல்ல எனக்கு எனி ஜெனரல் குவரிஸ் அபவுட் தி எக்ஸ்பெரிமெண்ட் வர முடியும் அப்படின்னு சொன்னா ஐ வில் கோ வித் தி ஃபர்ஸ்ட் ஒன். அதோட எக்ஸாம்பிள் தான் ஃபர்ஸ்ட் 2 சாய்ஸும். இதுல பாத்தீங்கன்னா என்ன பண்றேன் அப்படின்னா, ஃபர்ஸ்ட் டையோட வேல்யூ அந்த ஃபேஸ்ல இருக்க வேல்யூ வந்து should be 1 less than the second டை. அப்படின்னா நமக்கு என்ன ஆப்ஷன் இருக்குது, இப்ப ஃபர்ஸ்ட் டை வந்து 1 இருக்கிறப்ப செகண்ட் டை வந்து 2 இருக்கணும். அப்ப 1,2 வந்து ஒரு பாசிபிள் அவுட்புட். அடுத்த பாசிபிள் அவுட்புட் என்ன, 2,3. ஓகே, புரியுதா இல்லையா? அடுத்தது வந்து 3,4, அடுத்தது 4,5, அடுத்தது 5,3. அப்ப இதுல வந்து அந்த பேரோட வேல்யூஸ் எல்லாம் நம்ம ஆட் பண்ணிட்டு போனோம்னா நமக்கு வந்து எவ்வளவு வரும், 5/36 வருமா? அப்ப இதுல இருந்து அந்த இதை நமக்கு இன்சர்ட் பண்றது வந்து ஈஸியா இருக்கும். இந்த ஃபர்ஸ்ட் 2 கொஸ்டினுக்கும் இதுல இருந்து கம்ப்யூட் பண்றது இட் இஸ் ரியலி a hard task. நம்ம மறுபடியும் அந்த சாம்பிளை நம்ம லிஸ்ட் அவுட் பண்ணி தான் எடுத்துட்டு வரணும். சரியா? ஸோ அதை இல்லஸ்ட்ரேட் பண்றதுக்கு தான் இது கொடுத்தேன். மே நோ யோர் நேம்?
ஜெகன் மேம்.
ஜெகன். Thank you, Jagan. Okay.
Thank you, ma'am.
Any other questions?
That's it, ma'am.
Okay. Thank you. Thank you all. So we'll meet on